Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 7 video on the chapter of direct and inverse proportion, where I will solve the test paper 2, which is based on the concepts of the entire chapter of direct and inverse proportion. So this video is part of the CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the test paper 12 on the chapter of direct and inverse proportion. Okay, so I have written down all the questions from the test paper 12. So every chapter in the textbook of author R.S. Aggarwal, every chapter, at the end of every chapter, there is a test paper. You should always solve the test paper in a certain duration. Like roughly, most of the test papers have maximum 15 questions. So you must be able to solve the paper or solve all the questions in 45 minutes or maximum 1 hour. Now, as I always say that after solving any test paper or any problems from an exercise book, always recall and revise the concepts and the formulas that was used and applied to solve the problems. In this video, I will not do that because I have already done that a few times in the previous videos. And if you have not watched the theoretical videos on direct and inverse variation, I strongly suggest that you watch all the previous videos of this chapter. Okay, so let's start solving the problems. The first problem says that 350 boxes can be placed in 25 cartoons. How many boxes can be placed in 16 cartoons? So this is a straightforward question. Now the quantities involved are the number of boxes, as you can see, 350 boxes, and the number of cartoons. Now the thing to understand is that each cartoon has a specific size. So a fixed number of boxes can be placed in each cartoon. So if so if the number of boxes are more, obviously you will need more number of cartons. So let's identify the quantities x as number of boxes, and the quantity y as the number of cartoons, required to for the boxes to be placed. Now clearly we can see that the quantities x and y will vary directly with each other, because the more the number of boxes is, the more number of cartoons you will require, and the less number of boxes is, the less number of cartoons will require. This is based on the fact that all the cartoons must be of same size, and the cartoons have a fixed has a fixed capacity, that is a certain number of boxes can be placed in each cartoon. Okay, so now if you create the table of the data for the quantity x and y, so it is given that 350 boxes can be placed in 25 cartons. So we have 350 for x and 25 for y. Now it is asking how many boxes can be placed in 16 cartons. So let us assume that x1 boxes can be placed in 16 cartons. So we have this table, and applying the formula of two quantities x and y that vary directly with each other, we know that the ratio of all the corresponding values will be same. So we must have 350 divided by 25 should be equal to x1 divided by 16. So this implies x1 is equal to 350 multiplied by 16 divided by 25. Okay, so 5 divides 350 with 14, and 14 multiplied by 16 is how much? 14 multiplied by 16 is 84, and 14 which is 4 2 2. So x1 is 2 2 4. So 224 boxes can be placed in 16 cartoons. Now, whenever you solve problems on variation, always whenever you are finding some unknown values from the table, always see that your answer, your result is consistent with the type of variation that the two quantities are involved. In this problem, x and y are in direct variation. So if you when the so we have 350 boxes can be placed in 25 cartons. So and so it is asking how many boxes can be placed in 16 cartons. So if the number of cartons is decreasing, obviously the number of boxes will also decrease, and hence we can see that our result is 224, which is consistent with the variation. Okay. Let's do problem number 2. The cost of 140 tennis balls is rupees 4900. Find the cost of 2 dozen tennis balls. So the quantities involved are cost and the number of tennis balls. The number of tennis balls. Okay. Now it is obvious that the cost of more is the number of tennis balls, more will be the cost, because the cost of each tennis ball is fixed, that is not changing. So based on that, we can say that if x is number of tennis balls and y to be the total cost of the tennis balls, total cost of the tennis balls in rupees, then definitely x will vary directly with y. More is the so more is the number of um, in fact actually uh, the correct way of writing the variation is that more is the number of tennis balls, more will be the cost. So I think this is a more meaningful way of writing the variation, that is y varies directly with x. If there are more number of tennis balls, the cost will be more, and if there are less number of tennis balls, the cost will be less. Now, okay, so now let's tabulate, create the table of y and x. Okay, so it is given that the cost of 140 tennis balls is uh, rupees 4900. So 140, and over here for the quantity y is representing the cost of the tennis balls. So we have 4900. Now it is asking find the cost of 2 dozen tennis balls. 2 dozen tennis balls means 2 dozen means 24. 2 dozen means 24. So let us assume that the cost of 2 dozen, that is 24 tennis balls, is y1 rupees. So we have since y is directly varying with the quantity x, we must have y by x is a constant. So we must have 4900 divided by 140 should be equal to y1 divided by 24. So this implies y1 is equal to 4900 multiplied by 24 divided by 140. So 0010 cancels out, 2, 7, 2, 12, and 7, 70. So this is equal to 840. So 840 rupees 840 will be the cost of 24 tennis balls. Obviously, 140 tennis balls was costing rupees 4900. So So but 24 tennis balls which is less than 140 should cost less than 4900, and hence our answer is coming to be 840, which is consistent. So our result is consistent. Always check that your result is consistent or not based on the variation of the two quantities. Okay, let's do problem number 3. The railway fare for 61 kilometer is rupees 183. Find the fare for 53 kilometer. Okay, so the fare is one quantity, and kilometer, that is a distance. Obviously, this is based on the fact that the cost per kilometer is fixed. It is not changing. Then we can say that if we consider x as the distance in kilometer and y as the railway fare to travel a certain distance in rupees, then considering the fact that the cost of the railway fare per kilometer is fixed, we can say that y will vary directly with x. The more is the distance, the more will be the railway fare. Okay, so now let's create the table y x. So it is given that the fare is for 61 kilometer, that is 61, the fare is 183, and it is asking find the fare for 53 kilometer. So let us assume that the railway fare for 53 kilometer is y1. So we must have then the ratio of the constant y, that is y by x, should be constant for all the corresponding values. So we must have 183 divided by 61 is equal to 51 by 53. So this implies y1 is equal to 183 multiplied by 53 divided by 61. Okay, so 61 divides 183 with 3, and this is 159. So rupees 159. Rupees 159 is the cost of the railway fare for 53 kilometer. Now for 61 kilometer the cost was 183. So for 53 kilometer the cost must be less than 183, and hence our result is consistent. That is 159 is less than 183. Okay, let's do problem number 4. 10 people can dig a trench in 6 days. Okay, how many people can dig it in 4 days? So 10 people, the quantities involved that we have to consider is the number of peoples and the days, number of days required to dig a trench. Now, so these are the two quantities: number of people and number of people digging a trench, and the number of days required by the people to dig the trench. Now the thing to understand is that the amount of work is constant. The amount of work is digging a trench. Now the trench, I don't know exactly what a trench is. The dimension of the trench is fixed. It is not changing. So the amount of work, that is the digging a trench, the same trench, is fixed. So considering that, if we assume the quantity x to be number of people digging the trench, and y is number of days required. Number of days, I'm not writing completely. So the complete description of the quantity x should be the number of people digging a trench, and the y should be the number of days required to dig the trench. Number of days. So then we can say that y will vary inversely with x, because if there are more number of people, then the less they can dig the trench in less number of days, and if there are less number of people, then it will take more time, so more days. So the quantity y will be inversely proportional to the quantity x. So if we now create the table y and x, so it is given that 10 people is can dig a trench in 6 days. 6 days, okay. Now it is asking how many people can dig it in 4 days. Let's say x1 people can dig the trench in 4 days. So now, since the two quantities x and y are inversely proportional to each other, their product is constant. That is, the product of all the corresponding values in the table must be the same constant. So we must have 6 multiplied by 10 should be equal to 4 multiplied by x1. So this implies x1 is equal to 6 multiplied by 10 divided by 4, which is 60 by 4, which is 15. So 15 people can dig the trench in 4 days. Now, to check the consistency of our result, since 10 men, so if 10 men can dig the trench in 6 days, then definitely more people will be required to dig the trench in less number of days. That is in 4 days, and hence we are getting the result. The answer is 15, which is more than 10, and hence we can verify that our answer is consistent with the variation involved, which is inverse variation. Okay, let's do problem number 5. 30 men can finish a piece of work in 28 days. How many days will be taken by 21 men to finish it? So this is again the number of men, amount of work, and number of days kind of problem. So we can see the number of men and finish a piece of work. A piece of work is the constant amount of work. So this is the constant amount of work. So when the amount of work is constant, that is the same work, the work to be done is same, then the number of men doing that work and the number of days required to do that work, they are inversely proportional to each other. So if I consider x as number of days required to finish the piece of work, and the quantity y to be the number of men working on the piece of work. So we can say that the more is the number of men, the less number of days will be required. So definitely x is will vary inversely with y, or the quantity x and y will be in inverse variation. So now if we plot a table, not plot, sorry, if we create a table of the quantities x and y, so it is given that 30 men can finish a piece of work in 28 days. So 30 men can finish the work in 28 days. Okay. Now it is asking how many days will be taken by 20 men to finish the same work. To finish it means the same piece of work. So let us assume that x1 number of days will be required to finish the work by 21 men. So we can now say that since the quantities x and y are inversely proportional to each other, we must have 28 multiplied by 30 should be equal to 21 multiplied by x1. So this implies x1 is equal to 28 multiplied by 30 divided by 21. 7 3 7 4 3 3 10. So this is equal to 40. So it will take 40 days for 21 men to finish the work. Now let us quickly check the consistency of our answer. It was given that uh, it was given that 30 men can do the work in 28 days. So definitely 20 men, it will take more days for 21 men to finish the work, and hence we are getting the answer 40, which is more than 28. Okay, let's do problem number 6. A garrison of 200 men had provisions for 45 days. After 15 days, 40 more men joined the garrison. Find the number of days for which the remaining food will last. Now, this problem is a little bit conceptual. Is that it is saying that a garrison of 200 men had provisions for 45 days. So, the quantities involved are a number of men in a garrison and the number of days that the provision lasts. So, whatever the so this is about a number of men, provisions, amount provisions, and the number of days. The provision means the food. The amount of food is constant. So for a constant amount of food or provisions, it is saying that that food or provision will last for 45 days if the number of men in the garrison is 200. Okay. Now it is saying that after 15 days, 40 more men join the garrison. Now after 15 days, uh, now after 15 days, the scenario will be is that, so 15 days has passed by. Now 45 minus 30, 45 minus 15, 45 minus 45 minus 15 is 30. So in 15 days, some amount of food has been consumed by the 200 men. Now, so whatever food has been consumed and whatever food is left, based on the food left, the 200 men can survive for another 30 days, because it is given that 200 men will survive for 45 days on the provision available. So after 15 days, if 15 after 15 days, whatever food has been consumed, and based on the food that is left, definitely that food will last for another 45 minus 15, that is 30 days. So the scenario becomes that after 15 days, the scenario is that 200 men will based on the provision, the 200 men will last for 30 days. Now it is telling that 40 more men join the garrison. Find the number of days for which the remaining food will last. Okay. So the concept is that when the food is constant, the number of men and the number of days that the food will last, these two quantities are inversely proportional to each other. Since the amount of food is constant, if there are more men, definitely they will consume more food per day, and hence less number of days, the food will last for less number of days. And if there are less number of men, then the consumption of food per day will be less, and hence the food will last for more number of days. So if you consider x as number of men, x as number of men in garrison, and y as a number of days the provisions lasts. So whatever the provision is, if x is the number of men in the garrison, and y is the number of days that the men in the garrison will survive based on the provision, then these two quantities, we can say that x and y, quantities x and y, are inversely proportional to each other. So we can say that x y will vary inversely with x. That is, if there are more men, then the number of days the food will last will be less. Okay, now the important thing is to create the table y and x. So we have to consider the scenario after 15 days. So after 15 days, the scenario is that whatever food is left, that will last for 45 minus 15, that is 30 days. And still the number of men in the garrison is 200. So we can say that 200, we can enter the data 200 and 30, 30. So this is the scenario after 15 days. So after 15 days, the scenario is 200 men, whatever food is left, 200 men will, based on that remaining food, 200 men will last for or survive for 30 days. Now it is asking that if the number of men becomes 40 more, that is 240, if the number of men, it is saying that 40 more men join the garrison, which means that the number of men in the garrison becomes 200 plus 40, which is 240. Then for how many days the remaining food will last? So let us assume that for y1 days the remaining food will last when the number of men in the garrison is 240. So we must have 30 multiplied by, since the quantities x and y are inversely proportional to each other, we must have 30 multiplied by 200 is equal to y1 multiplied by 240. So this implies y1 is equal to 30 multiplied by 200 divided by 240. So this is 10 and 8 and 200 by 8, which is 25. So 240, so after 15 days, whatever food is left, based on that remaining food, 240 men will survive for 25 days. Because after 15 days, the scenario was that 200 men could survive on the remaining food for 30 days. So definitely 240 men will survive for less number of days, that is it will survive for less than 30 days, and hence our result is 25, which is consistent, 25 days. So this was subjective questions section A. Okay, next is section B, which are multiple choice questions. Okay, 6 pipes can fill a tank in 24 minutes. 1 pipe can fill the tank in, okay. So this problem we have already done earlier. So this is about that all the pipes are of same size. So when the pipes are of same size, then and the tank is the volume of the tank is constant, keeping the tank constant, or you can say the volume of the tank, the amount of water to be filled in the tank is constant, then the number of pipes and the time taken by the pipes to fill the tank will be inversely proportional to each other. So number of pipes, let's say x be the quantity representing number of pipes, even though it is not given in the problem, but you should keep in mind that all the pipes are of same size. So number of pipes of same size. Now y, time taken by the pipes to fill the tank. Now here the work done is constant, which is filling the tank, and the size of the tank or the volume of the tank is constant, it is not changing. So in this case we can say that the time taken to fill the tank by the pipes will be inversely proportional to the number of pipes. Okay, so now if we tabulate if we create the table X, Y, now the time taken by the pipes to fill the tank, let the unit of the time taken be in minutes. In minutes. Now let's create the table. It is given 6 pipes can fill a tank in 24 minutes. So 6 is the value of X and 24 is the value for Y. Now it is asking one pipe can fill the tank in. So X becomes 1 and let's say one pipe can fill the tank in Y1 minutes. So we must have 6 multiplied by 24. Since the quantity X and Y are varying inversely with each other, their product is a constant. So we must have 6 multiplied by 24 is equal to 1 multiplied by Y1. So this is equal to, so this implies Y1 is equal to 144. 144 minutes. Now always check the consistency of the answer. So if 6 pipes is filling the tank in 24 minutes, definitely one pipe will take more time, and hence we are having the answer 144 minutes, which is much more than 24. So the answer is choice D. Choice D is the correct. Choice D is the answer. Okay, let's do problem number 7. 14 workers can build a wall in 42 days. One worker can build it in. So this is about, again, number of men, constant work, and the time taken to do the work. The constant work is to building a wall. Building a wall is the constant amount of work. Now why is it constant? Because the workers are building, the length or the height of the wall is fixed, it is not changing. So uh, keeping the height or length of the wall same, you can say that the amount of work done is constant. So in that case, the number of workers and the time taken to build the wall will be inversely proportional to each other. So let's say if X denotes represent the quantity number of workers and Y is the number of days required to build the wall, then we can say that Y should be inversely proportional to X, because if the number of workers is more, then a less number of days will be required to build the same wall. Okay, and if the number of workers is less, it will take more time, more number of days. So if we now create a table of X and Y, the quantities X and Y, it is given that 14 workers can build the wall in 42 days. Okay, now it is asking one worker can build it in. So let's say one worker, that is one worker, can build the wall in Y1 days. So we must have 14 multiplied by 42 is equal to 1 multiplied by Y1. So this implies Y1 is equal to 14 multiplied by 42, which is equal to 28 and 56, which is 588 days. So if 14 workers are building the wall in 42 days, definitely one worker will take much more days than 42, and hence our result is consistent, that is 588 days. So the correct choice is choice D. Choice D is the answer. Okay, let's do problem number 9. 35 men can reap a field in 8 days. in how many days can 20 men repeat. So it is again okay example of number of men, amount of work which is constant, and the time taken, that is the number of days to complete the work. The work in this example is reaping a field. Now why it is constant? Because it is reaping the same field. Now the field must have some area, that is some length and breadth. So depending on the area, since it is the same field, the area is same, you can say that amount of work is same. So if the amount of work is constant, we know that the number of men doing that work and the number of days required to do that work, these two quantities are inversely proportional to each other. So let's say x be number of men reaping the field, and y be the number of days required to reap the field. Then we can say that y will be inversely proportional to x. That is, the number of days will be more if there are less number of men, and the number of days will be less if there are more number of men. Okay, so let's create the table of x and y. It is given that 35 men is reaping the field, can reap the field in 8 days. Okay, now it is asking in how many days can 20 men repeat. 20 men, let us assume that 20 men can reap the field in y1 days. So we must have 35 multiplied by 8 is equal to 20 multiplied by y1. This implies y1 is equal to 35 multiplied by 8 divided by 20. So 5, 4, 5, 7, 2, this is 14. So 20 men will reap the field in 14 days. Now since it was given that 35 men are reaping the field in 8 days, so definitely 20 men will reap the field in more than 8 days, and hence we are getting 14 days. So our answer is consistent. Okay. So the choice will be, the correct choice is A. A is the correct choice. A is the correct choice. Okay, let's do question number 10. A car is traveling at an average speed of 60 km per hour. How much distance will it cover in 1 hour 12 minutes? So it is about time, as you can see, time to cover a distance by a car traveling at a speed. So it is about speed, distance and time. Now it is asking how much distance will it cover in 1 hour 12 minutes. Remember that it is given that average speed means the car is always traveling at 60 km per hour. The speed is constant. So we know that for constant speed, when the speed is kept constant, uh, average speed, or sometimes it will be given as uniform speed or constant speed, it means the same thing. So for constant speed, we know, if we consider the quantities x to be the distance covered in a kilometer, and y to be the time taken to cover the distance in hour, then we know that the time taken will be the time taken will be directly proportional to x, because the speed is constant. If the distance is more, it will take more time, and if the distance is less, it will take less time. So the quantity y and x will be directly proportional to each other. Now let's create the table of the quantity x and y. it is given now. It is given that the car is traveling at an average speed of 60 kilometer per hour. So the speed is constant, but we are getting one data, that is in 1 hour the car travels 60 kilometer. So in 1 hour the car travels 60 kilometer. Now it is asking how much distance it will cover in 1 hour 20 minutes. Now we have to convert the 1 hour 12 minutes into hour. So 1 hour 12 minutes is equal to 1 plus 12 by 60 hour, which is equal to 1 plus 12 by 60 is 1 by 5 hour, which is equal to 6 by 5 hour. So let us assume that the car will travel a distance of x1 kilometer in 1 hour 12 minutes, which is equal to 6 by 5 hour, and I have no space left. Let me create some space. Okay. So since the quantities x and y are varying directly with each other, we must have 60 by 1 is equal to x1 by 6 by 5. So this implies 60 is equal to 5x1 by 6. This implies x1 is equal to 6 multiplied by 60 divided by 5. So this is 72. So 72 kilometer. So in 1 hour 12 minutes the car will travel a distance of 72 kilometers. So the correct choice is B. B is the correct choice. B is the correct choice. Okay. Question number 11. Rashmi types 510 words in half an hour. How many words would she type in 10 minutes? Okay. For this problem, you can consider the time taken to be the unit of time taken to be in minutes, because the question is asking how many words would you type in 10 minutes, and also it has given that in half an hour, which is 30 minutes, the Rashmi types 510 words. Now the quantities, if you consider the quantity, number of words typed and the time taken, these two quantities are directly proportional to each other, keeping in fact that the typing speed is constant, that is number of words typed per hour or typed per minute is the same, it is not changing. Then we can say if you consider x as number of words typed and the quantity y to be time taken to type the words, then definitely y will be directly proportional to x. More is the number of words, more the time Rashmi will take, because she is typing at a constant typing speed. Okay, so now let's create the table x, y. It is given that 510 words are typed in half an hour. Half an hour you can consider as 30 minutes. Now it is asking how many words would she type in 10 minutes. So let us assume x1 words is typed in 10 minutes. So we must have 510 by 30 is equal to x1 by 10. So this implies x1 is equal to 510 multiplied by 10 divided by 30. Okay, so this is 170. So 170 words will be typed in 10 minutes. So since the two quantities x and y are in directly proportional to each other, in 30 minutes, 510 words was being typed by Rashmi. So in 10 minutes, definitely less number of words than 510 will be typed, and hence our answer 170 is consistent. So the correct choice is C. C is the correct choice. Okay, let's do problem number 12. Okay, so it is given that x, this means that x varies directly with y, or the quantities x and y are in direct variation. Now it is also given that when x is when the value of x is 3, the value of y is 36. So if you create the table of x and y, it is given that when x is 3, y is 36. Now it is asking the value of x. Let's say it is x1 when the value of y is 96. Now since it is given that the two quantities x and y are directly proportional to each other, we must have 3 by 36 should be equal to x1 by 96. So this implies x1 is equal to 96 multiplied by 3 divided by 36. So 3 divides 36 with 12 and 8. So this is 8. So when the value of y is 96, the value of x is 8, and hence C is the correct choice. C is the correct choice. Okay, question number 13. It is given that x, the quantity x and y are varying inversely with each other. As it is given, x varies as 1 by y. Now, okay, so let's create the table. So it is given that when x is 15, the value of y is 6. Now it is asking what is the value of y when x is 9. So let's say the value of y is y1. Now since the two quantities are inversely proportional to each other, we must have their product to be a constant. So we must have 15 multiplied by 6 is equal to 9 multiplied by y1. So this implies y1 is equal to 15 multiplied by 6 divided by 9. So 3, 3, 3, 2, 3, 5. This is 10. So the value of y is 10 when the value of x is 9, and hence the correct choice is A. A is the correct choice. Okay. So that was section B, where all the questions were multiple choice question. Now we have sections C, which are all fill in the blanks. Okay. Question number 14, part 1. If 3 persons can do a piece of work in 4 days, if 3 persons can do a piece of work in 4 days, then 4 persons can do it in how many days? So again, this is number of men, work done, and time taken, that is number of days. Since the piece of work, the amount of work is constant, that is a piece of work, we can say x as, if you consider x to be the number of persons and y to be the number of days to complete the piece of work. The piece of work is constant, that is the amount of work being done is constant. Then we can say that the number of days will be inversely proportional to x. That is, when the amount of work is constant, then the number of days will be more when less number of men or persons are working, and it will be, the number of days will be less if there are more number of persons working. Okay, so now let's create the table of y and x. It is given that 3 persons can do the piece of work in 4 days. Now it is asking 4 persons can do it in 4 persons. So 4 persons, let's say 4 persons can complete the work in y1 days. So we must have 4, since the two quantities x and y are in inversely proportional to each other, their product must be a constant. So 4 multiplied by 3 must be equal to y1 multiplied by 4. So this implies y1 is equal to 4 multiplied by 3 divided by 4, which is equal to 3. So 4 men, uh, so 4 persons can do the work in 3 days. So the answer is 3. Okay, let's do problem number part 2. If 5 pipes can fill a tank in 144 minutes, then 6 pipes can fill it in this. Okay, so I'm not describing the description of the data types of the two quantities x and y. So x is the number of pipes and y is the time taken in minutes to fill the tank. Now here also, so this is about a number of pipes filling a tank which is constant. The work done is the work done in this problem is same. That is the work done is constant, which is filling a particular tank which has a specific volume. So the amount of work done is constant. So the number of pipes and the time taken to fill the tank are inversely proportional to each other. So let's say, anyway, write it. So x be the number of pipes, filling the tank, and the quantity y to be time taken by the pipes to fill the tank in minutes. So clearly the time taken to fill the tank will be inversely proportional to x. That is, the more the number of pipes is, the less time it will take, and the less number of pipes is, more time it will take. So let's create the table of x and y. So it is given 5 pipes can fill the tank in 144 minutes, and it is asking 6 pipes can fill the tank in how many minutes. So let's say 6 pipes can fill the tank in y1 minutes. So we must have 5 multiplied by 144 is equal to 6 multiplied by y1. So this implies y1 is equal to 5 multiplied by 144 divided by 6. This much minutes. So this is 24 and this is 120 minutes. So obviously, if 5 pipes are taking 144 minutes, then obviously 6 pipes will take less number of minutes, less than 144 minutes, and hence our answer 120 minutes is consistent. Okay, let's do part 3. A car covers a certain distance in 1 hour 30 minutes at 60 km per hour. If it moves at 45 km per hour, it will take how many minutes? So in this case, the speed is not constant. What is so this problem is about speed, distance, and time. Here the distance is constant. The car is traveling a certain distance. So certain distance. This is the distance is constant. So if the distance is constant, then the speed of the car for constant distance covered, for constant distance, if we consider the quantity x to be the time taken to cover the distance, let's say in hours, and the quantity y to be the speed of the car in kilometer per hour. So the time taken to cover the same distance, the distance is fixed. That quantity, let the quantity be x and the y, the speed of the car, then obviously the time taken will be inversely proportional to y. That is, if the speed is more, the time taken to cover the same distance will be less, and if the speed is less, the time taken will be more. Okay, so now if we create a table x and y, it is given that the car covers a certain distance in 1 hour 30 minutes at 60 kilometer per hour. So when the speed is 60 kilometer per hour, the time taken is 1 hour 30 minutes. Now, what is 1 hour 30 minutes? We have to convert 1 hour 30 minutes into hours. So 1 hour 30 minutes is equal to 1 plus 30 by 60 hour. This is equal to 1 plus 1 by 2 hour. This is equal to 3 by 2 hours. So 3 by 2 hours. Since we have considered the time taken to cover the distance, which is the quantity x, to be in hours. Now it is asking if it moves at 45 km per hour, it will take how much time? So let's say it will take x1 hour. It will take x1 hour. Now we don't have space. Let's create some space. Okay. So now we must have, since the quantity x and y are varying inversely with each other, we must have 3 by 2 multiplied by 60 should be equal to x1 multiplied by 45. So this implies the left hand side, if we simplify, is 3 by 2 multiplied by 60 is 90. So 90 is equal to 45 x1. So this implies x1 is equal to 90 by 45, which is equal to 2. So 2 hours. It is taking 2 hours. So to cover, if it moves, to cover the same distance, if the car is moving at 45 km per hour, it will take 2 minutes. Since definitely it will take 2 hours, and 2 hours is more than 1 hour 30 minutes. And our answer is consistent because the car covers the distance in 1 hour 30 minutes when it is traveling at a higher speed, that is 60 km per hour. So if the car is now traveling at 45 km per hour, that is less speed, then the time will be more, and hence we are having 2 hours, which is consistent. Okay. Part 4. If 8 oranges cost rupees 20.80, the cost of 5 oranges is. So this is about articles and cost. So articles and cost, as we know, they are always the number of articles and the cost of the number and the cost of the articles, they are directly proportional to each other. So x be the number of oranges and y be the cost of oranges in rupees, then definitely y will vary directly as x. So now if we create the table x and y, it is given that 8 oranges is cost is 20.80. So it is asking what will be the cost of 5 oranges. So let's say the cost is y1. So we must have, since the quantities are directly proportional to each other, we must have 8 by 20 by 50 is equal to 5 by y1. So this implies y1 is equal to 5 multiplied by 20.50 divided by 8 divided by, okay, 20.80. So this is 20.80. Okay. Okay, so let's create some space. So 5 multiplied by 20.8 is 40. mm, 10. Okay, 104 by 8, which is equal to uh, 13. So rupees 13. So the cost of 5 oranges will be rupees 13. Uh, since the two quantities are directly proportional to each other, if the cost of 8 oranges is rupees 20.80, then definitely the cost of less number of oranges will be less than 20.80. So the cost of 5 oranges is coming out to be rupees 13, which is less than 20.80. So the answer is consistent. Okay. The last one is the weight of 12 sheets of our paper is 50 grams. The sheets, how many sheets will weigh 500 grams? So again, if you considering the fact that the weight of a single sheet is same, the sheets are of same weight, each single sheets are of same weight, then the total if the number of sheets in a paper is more, then the weight will also be more. So if you consider x to be the number of sheets, the number of sheets, and y to be the weight of paper in grams. So x, the quantity x is number of sheets in a paper, and y is the weight of the paper in grams. So clearly we can say that more is the number of sheets, the y, uh, quantity y will vary directly with x, because more is the number of sheets, more will be the weight of the paper, and less is the number of sheets, less will be the weight of the paper. So if we create the table xy, it is given that 12 sheets, the weight is 50 grams. Now it is asking what will be the, how many sheets will weigh 500 grams. So let's say x1 sheets weigh 500 grams. Since the quantity x and y are in direct proportion, we can say that we must have 12 by 50 is equal to x1 by 500. So this implies x1 is equal to 500 multiplied by 12 divided by 50. So this is 120. So 120 sheets will weigh 500 grams, which is, the answer is consistent, because your 12 sheets weigh 50 grams, then definitely more than 12 sheets will weigh 500 grams, and hence the answer is 120, which is more than 20, more than 12, 10 times. Okay, so this brings to an end in solving the test paper 12 on the chapter of direct and inverse proportion given at the end of the textbook of author R.S. Aggarwal. So these questions were not hard, but these are based on fundamental concepts. Solving this test paper, you can evaluate whether your fundamental concepts are clear or not. So if this video was beneficial, please like it, share it with your friends, and also support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Now the next video will be homework number 2. I will solve the homework problems, the homework problem number 2, which will be based on both direct and inverse variation. So please stay tuned for the next video, which will be homework problem number 2. And then also keep an eye on the other playlist, that is Maths 8 Hot, where I will solve some harder problems, that is 10 good problems on the chapter of direct and inverse variation. So that is all for this video. Thanks for watching, and until the next video, take care and bye.